Hey everybody, as promised, the second half of our unit deals with graphing our polynomials. So I want to start off with reviewing our three we've already seen: linear, quadratic, and cubic, and then introducing quartic and quintic. When we have a linear, remember a linear is going to be a line, so it's either going to be going upward or it's going to be going downward. You can just go ahead and sketch these as we go. When we talk about a quadratic, remember that's going to be our parabola, so it's either going to be upward or it's going to be downward. And then when we have cubic, cubic is going to be our general snake shape or S shape, or it can come down this way as well. And then we add in quartic and quintic. Quartic is degree 4. Remember, quart, quarter, 4. So your shape is going to be either a W or it's going to be an M. And they won't always be symmetric, but we're going to draw them relatively symmetric just for the purposes of these sketches. When we get into quintic, quintic is degree 5, and when we talk degree 5, we're talking still again a snake shape, and that snake shape is just going to have a deeper curve to it. So it'll either look like this, or it'll look like this, and I know those overlap each other, but just so you have an idea of what they look like. So we start off by talking about end behavior, and end behavior is all based on what we call the leading coefficient test.
So the leading coefficient test tells the right and the left-hand behavior of a graph.
Which just means, does it go up or does it go down? So we have this formula which looks super complicated, where we have f of x equals a sub n to the times x to the n power plus a sub n minus 1 to the times x to the n minus 1 power, etc., 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 to a sub 2 times x squared plus a sub 1 times x to the first plus a sub 0. What that whole mess means is that your a sub n is your leading coefficient and your n of the leading coefficient is your degree. These tell you what happens to your graph. So if n is odd, so 3, 5 are the two that you're going to see, then you have to look at your leading coefficient. If it's positive, then that means you're going to have a general upward trend, that it's going to fall to the left, rise to the right. So even though it's got a dip in it, it's going to generally end up going upwards. Now, if the leading coefficient is negative, then it's going to have a general downward trend, so it'll shoot up to the left and down to the right. If we have an n that's even, so 2 or 4, that means that your end behaviors are either going to both rise or both fall. So just like a quadratic, when it's positive, it's happy. When it's sad, it's negative. It's the same thing with a quartic, and all it's doing is, instead of having your quadratic, it's putting a little kink in the quadratic to create that W. Or instead of having it down, just open downward, it's throwing that little kink in it to create the M. The other piece we want to talk about is multiplicity, and we've mentioned it a little bit.
Multiplicity is the number of times an x-intercept is repeated. An odd multiplicity, repeated an odd number of times, means that the graph goes through the x-intercept.
So, for example, that might mean we might have, say, x minus 3 to the third power, which what it means, the higher that multiplicity, means that when you get that graph that hits that x-intercept, it'll hover right at that space or look like it flattens out slightly before it drops through.
An even multiplicity, repeated an even number of times, means the graph bounces off the x-intercept.
So that's where we have, like we had a couple you saw in Unit 6, where you might, or Unit 7, where you have that squared. What that means is that as it comes down to the axis, it's going to come down, hit it, and come back up. It's not actually going to go through it. So what we want to start off doing is looking at some of the movements of some of these equations. So we will get into graphing specifically standard form tomorrow. But to start off, we look and it says n. N is going to be, in this case, 3 because the leading coefficient power is 3. The leading coefficient is negative 2 because that's what's leading out front. So that means it's negative, it's sad. So that means that my graph is going to do this, which means that 2, it's going to rise to the left and it's going to fall to the right because it's going up to the left, down to the right. Now for B, now we got it where we're going to graph. Here we talk degree. This one, I know you're going, well, do I have to get standard form? You don't actually have to get standard form for this. So I see 1, 2, 3 x's. That means my degree is 3. That means my shape is a snake or S shape. I know it doesn't look much like an S, so you can feel free to call it a snake. It has a leading coefficient that's going to be negative, and therefore my behavior has a downward trend. So it's going to rise to the left and fall to the right. And so now we look y-intercept. I know y-intercept, you're going, well, I have to FOIL it all out. You do not. What we'll do is we will take and put in zeros. So we got a negative 0 plus 3, 0 minus 1, 0 minus 2. So we have a negative with 3, negative 1, negative 2. Negative 1 times negative 2 is 2. 2 times 3 is 6. And there's a negative, which makes it negative 6. So my y-intercept is 0, negative 6. X-intercepts. These are easy enough because we have them already in factored form. We set each of these equal to 0, and we solve them, and we get x-intercepts of negative 3, 0, 1, 0, and 2, 0. And so now we need to graph those pieces. Graphing isn't as difficult as you think it is. It's a matter of putting these pieces on the graph and then getting the motion of the graph. We're sketching, we're not getting specific, other than we need to have some general points. We have 0, negative 6. We have negative 3, 0, 1, 0, and 2, 0. We know that this graph, as we look here, it rises to the left. It falls to the right. And we can see that this, we have 1, 2, 3, 4 points in between our zeros of negative 3 and positive 1. And so halfway in between is going to be negative 1. And so what we're going to do there is we are going to find some special points. And what this is just an additional point to help us with knowing how far our graph dips down. So I'm going to find the value of f of negative 1. Means I'm going to do the negative of negative 1 plus 3 times negative 1 minus 1 times negative 1 minus 2. Well, negative 1 plus 3 is 2, negative 1 minus 1 is negative 2, and negative 1 minus 2 is negative 3, and we got a negative out front. So negative 2 times negative 2 is positive 4, times negative 3 is negative 12. So that means that at negative 1, I'm going to be down at negative 12. So my graph comes way down here, spikes up, and comes up to here, because you won't have any to worry about any points in between. Now, 1 and 2 are very close to each other, so we typically go halfway in between. If I go halfway in between and do f of 1.5, that's going to give me the negative of 1.5 plus 3 times 1.5 minus 1 times 1.5 minus 2, which is the negative of 4.5 times 0.5 times negative 0.5, which comes out to 1.125. So not much higher than 1, so we go and we just calculate it in. And that's it for the graph. All right, so now let's try one more example. Here we've got x plus 1 quantity squared, so we have a multiplicity, times x plus 3. This squared tells me that there are two x's there plus one more, which means I have a degree of 3 again. That means my shape is going to be snake or S-shaped. And my behavior, I have all positives, which means it has a general upward trend, which means that it's going to fall this time to the left and rise to the right. So y-intercept, we've got 0 plus 1 squared times 0 plus 3. 0 plus 1 is 1, 1 squared is 1. 0 plus 3 is 3, 1 times 3 is 3, so 0, 3. X-intercepts, I've got negative 1, 0 with a multiplicity of 2, so I do have to list it out twice. And negative 3, 0. So now, we'll go ahead and graph those. So we've got 0, 3. We've got negative 1, 0, and negative 3, 0. We know that it trends upwards, so we go here. We know that it bounces at negative 1, so we're going to draw the bounce. We don't know how high it goes in between negative 1 and negative 3, so we're going to find f of negative 2. If I do that, I get negative 2 plus 1 squared times negative 2 plus 3. So we've got negative 2 plus 1 is negative 1 squared is 1, and negative 2 plus 3 is 1, so 1 times negative 1, or 1 times 1, which is 1. So it curves up, and I'm going to redraw that a little bit since I sketched that kind of wonky. And so what I get here is it comes up to 1, and then it bounces and comes back up again. So this one doesn't have much of a dip in between. So now that I've taken 12.5 minutes of your time to go through this, I want you to give this one a shot. We've got x squared, there's a multiplicity there, times x minus 2 times x plus 2. And we will discuss this and answer questions in class tomorrow.